Okay, so mass-to-mass stoichiometry is a combination of both of mole ratios, which was a lesson we did, I think was Boliva's previous lesson, and converting moles to grams and grams to moles. So we're going to combine two topics that we have covered before, and we're going to apply to one. But we're going to start slowly. So the first thing that you do when you're trying to solve this problem, well, is read and then read the question again. So here's the combustion of butane, which it shows here the formula for butane, and it produces 2.46 moles of water. So the combustion of this chemical produces this amount of water. And so note here, I left you a note. Since it is in moles, you do not need to worry about molar mass. All you need to worry about is mole ratio. Okay? So I put questions A, B, and C here to walk you through the process of different mole ratios. This is actually a typo, and you don't have this because I already fixed the typo, but on my version you still have it. So the first thing that it's asking is how many moles of water was formed. Well, it says it in the problem. So 2.46 moles of water, or H2O. Okay, so it already says it in the problem. So the second problem asks how many moles of butane was burned. Okay, so in that case, now we need to do some mole ratio. We know we have, let me get closer, we know we have 2.46 moles of water, and I'm putting on top just because I ran out of space. Okay. And I know that if I look at my mole ratio, there are 10 moles of water per 2 moles of butane. C4H10. Okay, so the mole ratio here is 10 to 2. Okay, 10 moles of water to 2 moles of butane. I know I did this correctly because the unit should cancel. Okay, cancel unit, cancel unit. So now my answer is going to be 2.46 times 2 divided by 10. Okay. And that is going to be 0.492, and the units here are moles of butane, which is C4H10. Alright, let's move on. How much oxygen was used up in moles? Okay, let's look that up. We're just going to use the water again, although we could use butane because they're all the same ratio, right? They're all in the same equation, I meant. So let's look. We have 2.46 moles of water. Okay. Now it is going to be between water and oxygen. Okay, so we're going to use those two mole ratios. Okay, so it's going to be between this and this. Okay, so I would say again for 10 moles of water, okay, there's 13 moles of O2. Again, I double check myself. This red pen is done, so I'm going to use this black one. Okay, so that looks right because my units cancel. 2.46 times 13 divided by 10, it gives me 3.198 in the units of moles of oxygen. Okay. So this was, there we go. So this was a little bit of a review because we've done mole ratios before, right? We're just looking for what's given and what we want, and we look at the coefficients here. So obviously you have to have a balanced chemical reaction for this to work. All these problems here give you a balanced chemical equation. So this was a little bit of a review of mole ratio. So now let's go into the new topic. So it's the same question. Okay, the combustion of a sample butane produces, now instead of 2.46 moles of water, it's using 2.46 grams of water. Well, that significantly makes things a little more difficult. Okay, so the first thing that we're going to do is calculate the molar mass of all the reactants and products. Okay, so remember, to do molar mass, you have to look in a periodic table and find the mass of the individual elements, see how many of them are present, and then add them up. I'm going to do it really quickly. So we have, let's start with butane. Okay, we have 4 times 12, and I'm just rounding here because I won't round it, plus 10 times 1.01, and I get a molar mass of 58.14 grams per mole. Okay. And I'll do the same thing for the other one. So I have so O2, so I have, okay, O2, sorry, 16 times 2 is 32. So O2 is 32 grams per mole. Water, I know, is 18. Okay, water is 18 grams per mole. And then carbon dioxide, 12.01 plus 32 is 44. CO2 equals 44.01 grams per mole. So I have the molar mass, and I use the periodic table to get there. I got my molar masses. So now let's start reading what the problem is asking. So the problem is asking how many moles of water was formed. Okay. I have grams of water, so step 1 is to convert grams to moles. Okay, so, and we're going to use molar mass to do that. So we have 2.46 grams of water. Okay, I know where's my water. My water is right here. I have 18 grams of water in 1 mole. So putting that in my calculator is going to give me 2.46 times 1 divided by 18. And that gives me 0.137 moles of water. Alright. Now, going to part B. How many moles of butane was burned? Well, I'm going to do the same thing I did before on the first example I showed you. I'm going to do mole ratio. Okay. So I know I have 0.137 moles of water. Okay, it's right here. And I know, let's look at the mole ratio. It's the same as before, 10 moles to 2 moles. So the mole ratio is 10 to 2. Okay, so here we go, 10 moles of water to 2 moles of butane, C4H10, there we go. Alright, and then plugging into my calculator, I get 0.137 times 2 divided by 10. 0.0274, and that is moles of butane. So let's just get going. How many grams of butane was burned? Okay, so I have moles of butane. I need grams of butane, so I need to go from moles to grams. Again, let's pick this one up. 0.0274, and that is, I ran out of space, moles of C4H10. Okay, and I have the molar mass of butane, which is 58.14. There is in 1 mole of CH10, there's 58.14 grams. And let's see. By the way, notice that this problem is completely the opposite. I just flipped everything. How do you know when to multiply and when to divide? You really have to follow the units, and you see how the units here cancel. So we have that number still from my calculator from the last time, so I'm just going to multiply that by 58.14, and that gives me 1.59, and that is going to be grams of C4H10. Okay, notice how I went grams to moles, moles to moles, and then moles to grams. Alright, how much oxygen was used up in moles? Okay, what we need to do, we need to go back to moles of water. So moles of water. Instead of butane, we're going to use oxygen, just like we did in the previous example. So 0.137 moles of water. The mole ratio here is 10 to 13. So 10 moles of water to 13 moles of O2. Okay, and I know this cancels out. Alright, so in my calculator, I'm going to do 0.1137 times 13 divided by 10, and that's going to give me 0.178, and that is moles of O2. And then finally, how much oxygen was used up in grams? So we're going to go from moles to grams. So okay, molar mass of oxygen is right here, is 32. Okay, so very similar to what I did in the previous example, except I used the molar mass of oxygen. Alright, the next problem is yours. I worked on the steps slowly in the beginning, and then I gave you a few free ones for you to try.